Hi, I'm going to have a hands-on look at DarkFi, an anonymous layer 1 blockchain that has native zero-knowledge proof-based smart contracts. So, this here is their website. We've got an overview, a manifesto, insights with some news and updates, information about the Internet Relay Chat community, some documentation, media, and a link to some merch. If we go over to the documentation, we can quite quickly get up and running. Here we've got the build instructions, so we git clone, cd into the directory and check out the branch. Then if we need to, install Rust. In the contrib directory, we have a script which installs dependencies appropriate for your operating system. And then we can do a make. Once the binaries have been built, we need to get up and running and start syncing with the other nodes on the testnet. In the documentation on the website, we want to go over to the user guide and running a node. First time you run the DarkFi daemon binary, a default config file will be created. Just run it again and the daemon will start syncing with the other nodes on the network. We can move on to creating a wallet and scanning the blockchain. Once we've got our address, we can put it in the config file for the DarkFi daemon, which will be the payout address for when you start mining. It's definitely a good idea to set up some service units so you can leave the node running on in the background. After our DarkFi node has synced with the other DarkFi nodes on the network, we then need to scan the blockchain to find any contract calls related to our address. The project also has their own chat software, which is something that is overlooked in other cryptocurrency projects, as you do actually need some form of trusted communication to relay information related to more complicated operations like multi-sig transactions or DAO voting. And by having their own chat program, they can make that experience more seamless. Rather than waiting to try and mine a block, I'm going to use their chat program to beg for some testnet tokens. Then with a sync testnet node, some tokens, you're ready to start playing with the testnet. For time and convenience, I'm now going to switch over to using a local net as I work through the examples in the DarkFi documentation. Already in the project, there are several local net configurations that you can use and start working with. So there's a single node setup here and a small cluster of nodes as well. First thing we come to is creating tokens. So on the DarkFi network, we are able to mint custom tokens with some supply. To do this, we need to generate a mint authority key pair and derive a token ID from it. So we call DarkFi token generate mint, and that will give us our ID. In this example, we're going to generate 2 tokens. So aliases. To make our lives easier, we can create token ID aliases so that when we are performing transactions with them, we can just use that instead of the full token ID. The native token alias DRK should already exist, and we can use that to refer to the native token when executing transactions. To create a new alias, we call dark alias add and then the alias name, in this case anon, and then the token ID. Next, we need to perform a mint. Now let's mint some tokens for ourselves. First, grab your wallet address and then create the token mint transaction. Dark token mint alias token amount, your address, and then output that to a file, and then call dark broadcast. And then if we look at the blockchain explorer, we can see that the transaction has been broadcast, and once it has been mined, we'll see that our wallet balance has been updated. Using the tokens we minted, we can make payments to other addresses. So we call dark transfer token amount, then token alias, and then the address we are sending to. And then we call dark broadcast. We've next got atomic swaps. In order to do an atomic swap with someone, you will have to first agree on what tokens you wish to swap. To protect your anonymity from the counterpart, the swap can only send entire coins. So first we initiate the swap and build our half of the swap transaction. So dark OTC init, and then the swap ratio and the type of the tokens to be swapped. Then you can send this half swap file to your counterpart and they can create the other half and sign it. And then once the counterpart has that half swap, they can sign it by running dark OTC join, inputting the half swap data and outputting the full swap data. And then they send it back to you and you have to sign it. So dark OTC sign, inputting the full swap data and outputting signed swap data. Now that the swap is signed, one of the parties or a third one must attach the corresponding fee. So dark attach fee, input the signed swap data and output full swap with fee data. Since a new call has been added to the transaction, both parties must re-sign the full swap with fee file one by one. So party A, dark OTC sign, input the full swap with fee data and output signed full swap with fee. Party B, dark OTC sign, input the signed full swap with fee data and output swap transaction. And then one of the parties must broadcast that data to the network. And once it's been mined and confirmed, we can then check the balance has been updated. So we can see that the spent flag is false, showing that the transaction was successful. Being able to anonymously swap assets is fundamental for business. It's something that JP Morgan was attempting to pursue in their Project Epic. If we look at their white paper for Project Epic, we see in their chapter Reflection on Outcomes, zero-knowledge proofs are particularly compelling for fund tokenization as they enable critical verifications while maintaining confidentiality. Fund managers can validate investor eligibility, process transactions, and meet compliance requirements without exposing sensitive data. But then again, cryptographic proof of asset swaps is very different to how banking is described in books like Lombard Street, in which London banking is described to be more like liquidity insurance. We now move on to DAOs, decentralized autonomous organizations. On the testnet, we are also able to create an anonymous DAO using the Dark command line tool. DarkFi DAOs have several configurable parameters, including proposer limit, the minimum amount of governance tokens needed to open a proposal. Quorum, the minimum threshold of participating total tokens needed for a proposal to pass. Early execution quorum, the minimum threshold of participating total tokens needed for a proposal to be considered as strongly supported, enabling an early execution. Approval ratio, the ratio of winning total votes needed for a proposal to pass. Governance token, the DAO's governance token ID. Let's create a DAO with the following parameters: proposal limit of 20, quorum of 10, and early execution quorum of 10. approval ratio of 0.67, governance token of Anon. To create the DAO, we use DAO create, and then the proposer limit, quorum, early execution quorum, approval ratio, and governance token ID. And we can view it with DAO view, and then we can import it with DAO import with the alias that we want to give this DAO. And then if we call DAO list, we will see the imported DAO. And then to view its data, we call DAO list and then the alias given to the DAO. We use the DAO name to reference it. Now we can create a transaction that will mint the DAO on chain if we hold all its keys. So DAO mint, DAO alias, and then we call dark broadcast. Now the transaction is broadcast on the network. We wait for it to confirm, and if your dark is subscribed, after confirmation you should see a leaf position and a transaction hash when running. Sending money to the treasury. Let's send some tokens to the DAO's treasury, so we're able to make a proposal to send those somewhere. First, find the DAO bulla, the DAO contract spend hook, and the DAO notes public key. So if we call DAO spend hook, we will get our spend hook, and then if we call DAO list and the alias of the DAO, we will have all of the data, which includes the bulla and the notes public key, which we need to transfer money. So then we call dark transfer, number of tokens, the alias of the token, then the DAO notes public key, the DAO contract spend hook, and the DAO bulla. And then we do dark broadcast, inputting the transfer data. Once it's confirmed, we can call dark DAO balance with the alias of the DAO, and we will see that the DAO now has the tokens we sent it. Now that the DAO has something in its treasury, we can generate a transfer proposal to send it somewhere that will be up to vote for 1 block period if we hold the DAO proposer key. So we call dark DAO propose transfer, the alias of the DAO, the 1 block period, the number of tokens, and the token alias, and then the address we want to send it to. After the command was executed, it will output the generated proposal bulla, which we will use to view the proposal information. We can export this proposal to share with the rest of the DAO members. The exported file will be encrypted using the DAO proposal's view key, so only its members can decrypt and import it. So dark DAO proposal bulla, export, and then we can use dark DAO proposal import to import that data. Now we can create the proposal mint transaction with dark DAO proposal bulla, mint proposal to create the transaction data, and then we use dark broadcast to broadcast it. Members that didn't receive the encrypted file will receive the proposal when they scan the corresponding block, but its plain text data will be missing, so they should ask the DAO for it. Once confirmed and scanned, you should see a leaf position and a transaction hash when running dark DAO proposal bulla. Next, we need to be able to vote on a proposal. Now the DAO members are ready to cast their votes. We have dark DAO vote and then the bulla of the proposal, and then your vote, 0 or 1, and then an optional wait. So we're going to call dark DAO vote proposal bulla 1 for vote yes, and that will give us our proposal vote data, and then we broadcast that. And then when we call dark DAO proposal bulla again, we will see that it has our vote listed there. executing the proposal. Once the block period has passed and enough votes have been cast that meets the required minimum quorum, and assuming the yes-no votes ratio is bigger than the approval ratio, then we are ready to confirm the vote. Only DAO members with the executor key can perform this action. So dark DAO EXEC with the flag early, then the proposal buller, and that will give us our execution data to then broadcast on the network. After the proposal has been executed on chain, we will see the DAO balance has been reduced if we hold the DAO notes key, while our own balance has been increased by the same amount. So with this, we could have a democratic system that isn't inauthentic and jovial. In conclusion, DarkFi is a very interesting project. When crypto first came about, there was all this talk about change the money, change the world. But as it turns out, there's more to international money power than just money. There's messaging services, for example, like SOFA, or there's futures contracts that businesses rely on to function in the real world, all of which are, of course, anonymous and private. Perhaps tooling provided by projects such as DarkFi can offer alternatives to the systems that international money power provides, and perhaps they could create some change. Who knows?